are going to study sexual reproduction in angiosperms. Sexual reproduction, as we already studied, is a type of reproduction in which the fusion of gametes take place. Gametes are always haploid, and there is a fusion to form a diploid zygote. The gametes can be, in case of plants, the plants can be bisexual or unisexual. When the plants are bisexual, they are called monoecious plants, and both the gametes, that is the male and female gametes, are produced in single body. And when the plants are unisexual, they are called dioecious plants, and they are capable of producing only one type of gamete. So the plant will be either male plant or female plants, and two different type of plants are required in order to produce a seed. Now, angiosperms, as you know, are those plants in which the seeds are found covered by fruits. The fruits is actually formed by the ovaries, and ovaries are only found in the flowering plants, and that's why all the angiosperms are always flowering plants. Now, the life of the sexually reproducing plants, as we already studied, is completed into three phases: the pre-reproductive, reproductive, and post-reproductive. Pre-reproductive is the vegetative growth, in which there is no reproductive capability is found, sexual reproduction capability. Of course, the plants can even undergo a sexual reproduction or vegetative propagation, that is out of context of this chapter. So sexual reproduction capabilities develop only once they reach to the sexual maturity and they develop the flower. So onset of sexual reproduction is characterized by the formation of flower. A flower is formed from a floral primordium, and it is already been decided where a flower has to develop. We already studied the different type of inflorescences, and two major inflorescences which we studied in class 11th are the racemose and cymose, and accordingly we know that whether the flower will be born at the tip or whether the flower will be born on the axis. The cymose will always form the flower on the axis, whereas the racemose will never form flower on the tip, so it will continue to grow. So the floral primordium will decide that where the flower has to be given rise. A flower is actually having four different parts, that is the sepal, petals, endoecium, and gynoecium. The sepals are actually meant for protection of a young flower, that is a bud, whereas the petals are actually meant for attraction of various type of agents of pollination. The agents of pollination can be birds, or it can be insects, or it can be certain type of animals. And even along with this, there are some plants also produces some type of scent, some type of nectar, or some other type of things, or sometimes they also having certain type of microorganisms like insect, etc. living there, which will be becoming food for the other birds or other animals. So all these, knowingly or unknowingly, they are carrying out pollination. So pollination we'll study in the next topic, so I'm not wasting my time here in pollination. The stamen and pistil are the two reproductive part of a flower. The stamen is the male reproductive part, and the pistil is the female reproductive part. We shall study about the male reproductive part here. That is the male reproductive part. Stamen is consisting or divisible into two parts, that is the anther and the filament. Anther is, in case of plants, is actually bilobed. Left and right two lobes can be seen, and then each lobe is further divided into two chambers. So each anther is dithecous. If we cut a cross section, we'll find four different regions where the sporogenous tissues are found in the four corners. And if we look at it, if we magnify it, we will find that there are four different type of layers are there. The outermost layer is made up of thick epidermis. Epidermis is further protected by a waxy and non-cellular layer that is called cuticle. Cuticle provides protection and prevents the loss of water and all. Then inner layer is, further down layer is endothecium, and then further 2-3 layers of middle layer are there. So all three layers, that is the epidermis, the endothecium, and middle layer, they are providing protection. Then comes tapetum. Tapetum is a layer of cells in which there are two nuclei. So you can recollect that the two nuclei in a cell can be formed when the nucleus is undergoing the nuclear division, that is karyokinesis, but it failed to undergo cytokinesis. Then each cell will have two nuclei. When it has got two nuclei, naturally it will have extra material, so it will be responsible for providing nourishment. So it provides nourishment to the sporogenous tissue, which are responsible for the development of pollen grain. Sporogenous tissue is the cells which are responsible for undergoing the microsporogenesis, and they will form pollen grain. There are hundreds of thousands of pollen sporogenous tissue, and each of the sporogenous cells is capable of producing a pollen grain. Now, once the sporogenous tissue becomes mature, then it may be known as microspore mother cell or pollen mother cell, MMC or PMC. The PMC or MMC is a diploid cell. This diploid cell first undergoes first meiotic division, and it will reduce into haploid, and two cells are formed. Two haploid cells, then they again undergo second meiotic division, and they will produce four haploid cells. Each cell then they are found together here, and it is known as microspore tetrad. Then the cell separates, and once the cells separate, then it forms two layers: the inner layer INTINE and the external layer EXINE. INTINE and EXINE are entirely different in their properties. If you see, EXINE is rough, INTINE is regular. EXINE has number of places it may be thick or thin, whereas INTINE is uniformly thick. EXINE is made up of sporopollenin, whereas the INTINE is made up of cellulose. The EXINE is made up of it has got a structure which is having different type of ridges and different type of architecture, which you can see, whereas the INTINE is regular. So this is what the differences are. Then it has got one single haploid cell. Now this single haploid cell undergo first mitotic division, and it will produce two nuclei, one large nuclei that is called vegetative cell, and the other small nuclei that is called generative cell. There is only one cytoplasm. Most of the cytoplasm is occupied by the vegetative cell, and the generative cell is only found suspended in that. Most of the plants, the new pollen grain is shed in this stage only. That is 60% species of the total angiosperm plants, they shed their pollen grain in two cell stage, whereas there are 40% of the angiosperm plant in which the generative cell again undergoes second mitotic division, and they will produce two male gametes. So they will have three cells. The 40% species of the angiosperm, they shed their pollen grain in three cell stage. Even those plants which are having two cells, they will also, when the pollination takes place and the pollen tube is formed, their generative cell will again give the undergo the mitotic division, and it will produce two pollen grains. So the result is same, but the location, the time is different. So 60% with two cells and 40% with three cell stage are there. So this is all about the male gamete, how the male gametophyte, pollen grain is male gametophyte. So this is how the male gametophyte is developed. Male gametophyte will further develop, and it will produce the male gamete, that is two male gametes. One of the male gamete will fuse with the egg, and the other male gamete will fuse with the pollen body. That will study in the next module. So this is all about today. If you got any doubt in whatever studied today, you can ask me in the comment section down, and your questions will be definitely answered. And if you like the video, what you have to do, that is you have to like the video, share it with the other children, and if you are new on my channel, then you have to subscribe and press the bell icon so that you get the notification regarding new videos. Thank you.